Imagine staring at a digital tablet that knows precisely when you are about to forget a mathematical concept, adjusting the difficulty of the next question milliseconds before your frustration peaks. This is no longer the domain of science fiction, but the reality of modern educational environments. Across the globe, silent algorithms are analyzing over 350,000 data points per hour to map the unique cognitive architecture of individual students. We are witnessing the end of the one-size-fits-all era of schooling. For over a century, the industrialized factory model of education processed human minds through standardized assembly lines, hoping a single lecture could reach the median of any given room. That paradigm is fracturing. At the intersection of human pedagogy and automated systems, a profound transformation is taking place. This binary bridge connects the deeply human endeavor of learning with the relentless pattern-matching power of artificial intelligence. It is a fundamental rewiring of how knowledge is transferred and acquired. To understand this shift, we must look at the engine driving it, a subset of artificial intelligence known as machine learning, where computer systems automatically improve their performance through experience and data exposure. Rather than being explicitly programmed with rigid rules, these algorithms ingest vast amounts of student performance data to find hidden patterns. When applied to education, this technology creates dynamic, ever-evolving curricula that treat every single learner as an entirely unique data set. The most visible manifestation of this technology is the rise of adaptive platforms. These digital environments do not simply present information, they actively respond to the user. If a student breezes through quadratic equations, the platform accelerates the pace, bypassing redundant exercises to maintain engagement. Conversely, if a student struggles with fractions, the system immediately identifies the exact missing foundational concept and serves up targeted interventions, scaffolding the learning process in real time. Researchers at Carnegie Mellon University have been at the forefront of this, developing cognitive tutors that model the psychological states of learners. By tracking how a student solves a problem step by step, these AI tutors can pinpoint the specific misconception causing an error. Instead of just marking an answer wrong, the system offers a tailored hint, nudging the student toward the correct logical leap. It mimics the nuanced, patient guidance of an expert human tutor. But what happens when the machine knows your cognitive blind spots better than you know them yourself? The psychological impact of such intimate academic surveillance is profound. Students interacting with these highly personalized systems often experience a drop in the anxiety typically associated with high-stakes testing. Because the environment adapts to their specific pace, the stigma of falling behind is erased, replaced by a solitary, frictionless dialogue between the learner and the code. Beneath the surface of this frictionless dialogue lies a complex architecture of predictive modeling. Data scientists utilize a technique called Bayesian knowledge tracing to constantly update the probability that a student has mastered a specific skill. Every click, every pause, and every self-correction feeds into a mathematical model that predicts future performance. This continuous loop of assessment and adjustment ensures that the student is always operating at the optimal edge of their ability. The echoes of those early cognitive models now guide entire digital ecosystems. We see this in the deployment of AI-driven conversational agents, designed to provide instant, natural language feedback. A student writing an essay at 2 in the morning can receive immediate critique on thesis structure and syntax from an automated assistant. This round-the-clock availability democratizes access to feedback, breaking down the temporal barriers that once limited academic support to school hours. Educational psychologist Benjamin Bloom famously identified the 2 sigma problem in 1984, demonstrating that students who receive one-on-one tutoring can experience a 98.6% improvement in performance compared to those in traditional classrooms. For decades, scaling this level of personalized attention was economically and logistically impossible. Now, artificial intelligence offers a tantalizing solution to this historical bottleneck. By deploying intelligent algorithms, we are attempting to mass-produce the benefits of individualized instruction. This technological leap inevitably forces a redefinition of the human teacher. If a machine can deliver content, grade assessments, and identify knowledge gaps with superior efficiency, the traditional role of the educator as a mere broadcaster of information becomes obsolete. Instead, the teacher is elevated to the role of an orchestrator, a mentor, and an empathetic guide. The classroom transforms from a lecture hall into an active laboratory of collaborative problem-solving. Freed from the burden of endless grading and repetitive instruction, educators can focus on the distinctly human elements of teaching. They can foster emotional intelligence, mediate complex debates, and inspire critical thinking. Armed with comprehensive dashboards that visualize the real-time cognitive state of every student, teachers can intervene precisely when human empathy is required. The algorithm handles the mechanics of knowledge acquisition, while the human nurtures wisdom and character. The real challenge lies in navigating the ethical minefield this level of data collection creates. To personalize learning, these platforms must harvest an unprecedented volume of student data. Every interaction is logged, creating a sprawling digital footprint that tracks not just what a child knows, but how quickly they learn, how often they fail, and how they react to frustration. The question of who owns this cognitive profile and how it might be used in the future remains fiercely debated. Privacy advocates warn of a future where a student's early academic struggles, permanently etched into a corporate server, could influence college admissions or future employment opportunities. If an algorithm determines that a 9-year-old has a low probability of mastering advanced calculus, does that prediction become a self-fulfilling prophecy? The risk of digital determinism is a heavy shadow hanging over the promise of personalized education, demanding rigorous regulatory frameworks. To address these concerns, researchers at institutions like the Massachusetts Institute of Technology are pioneering techniques in federated learning. This approach allows AI models to train across multiple decentralized devices holding local data samples without actually exchanging the sensitive data itself. By keeping the raw information on the student's personal device while still improving the global algorithm, developers are attempting to bridge the gap between necessary data analysis and fundamental privacy rights. Beyond privacy, there is the insidious threat of algorithmic bias. Because machine learning models are trained on historical data, they can easily inherit and amplify existing societal inequalities. If an AI tutor is trained primarily on the linguistic patterns and cultural references of a specific demographic, it may misinterpret the valid but different approaches of students from diverse backgrounds. An algorithm designed to optimize learning could inadvertently penalize those who do not fit the historical mold of success. Yet, when engineered with intentional inclusivity, these same technologies hold the power to level the global playing field. Consider a student in a remote, under-resourced village gaining access to the exact same adaptive algorithms used by elite preparatory schools. Through a simple smartphone connection, the barriers of geography and socioeconomic status begin to dissolve. The AI does not care about zip codes, it cares only about the cognitive progression of the user on the screen. This democratizing force is particularly potent in the realm of language acquisition and special education. For students with dyslexia or ADHD, traditional classrooms can be overwhelming and punitive environments. AI systems, however, can instantly adjust text formatting, alter audio speeds, and provide multimodal representations of concepts. What was once labeled a learning disability is increasingly recognized by the machine as simply a different data pathway, requiring a different algorithmic approach. As we push further into this frontier, the underlying architecture of these systems is becoming exponentially more sophisticated. Developers are increasingly utilizing neural networks, which are complex algorithms modeled loosely on the human brain, designed to recognize patterns across vast, unstructured data sets. These networks allow educational software to process not just multiple-choice answers, but open-ended essays, spoken language, and even creative coding projects, evaluating deep comprehension rather than rote memorization. The implications of this deep processing are staggering. Imagine an AI that can analyze a student's historical essay, not just for grammar, but for the nuance of their argumentation, cross-referencing their logic against millions of other texts to provide hyper-specific feedback. The machine becomes a tireless intellectual sparring partner. It pushes the student to refine their thesis, challenging weak assumptions and suggesting obscure historical sources tailored perfectly to the student's specific line of inquiry. And this is just the beginning of the sensory expansion in educational technology. The next wave of future classrooms aims to incorporate affective computing, where systems use computer vision and biometric sensors to read a student's emotional state. By analyzing facial expressions, posture, and eye tracking, the AI could detect boredom, confusion, or flow states. If a student's eyes glaze over during a physics simulation, the system could automatically pivot to a more interactive, visually stimulating module. The digital pioneers who set this course envisioned exactly this kind of seamless symbiosis. The integration of emotional recognition into learning platforms represents the ultimate merging of human psychology and machine logic. It acknowledges that learning is not merely a mechanical transfer of data, but a deeply emotional and psychological journey. The machine is learning to read the human, just as the human learns from the machine. Critics argue that introducing biometric surveillance into schools crosses a dystopian line, reducing the rich, unpredictable messiness of childhood development to a series of optimizable data points. They caution against a future where students are conditioned to perform for the algorithm, suppressing natural variations in mood and attention to satisfy the machine's metrics. The debate over effective computing strikes at the very heart of what it means to be a free-thinking individual in a quantified world. The tension between optimization and humanity will define the next decade of educational design. As we integrate these powerful tools, we must actively resist the urge to automate the soul out of the classroom. The most successful future learning environments will not be those governed entirely by cold logic, but those that deliberately design spaces for human friction. We need moments of unscripted curiosity, collaborative failure, and the serendipitous discoveries that no algorithm can predict. Ultimately, the rise of artificial intelligence in education forces us to hold up a mirror to our own pedagogical values. It strips away the logistical constraints that have dictated schooling for centuries, leaving us with a profound question. If a machine can teach a child how to calculate, code, and conjugate verbs faster and better than we ever could, what is the essential human knowledge we must pass on? The answer lies not in the curriculum, but in character. This binary bridge we are building is not a replacement for human connection. It is a scaffolding that elevates it. By delegating the mechanics of personalized learning to intelligent systems, we free future generations to focus on creativity, empathy, and the complex moral reasoning that machines cannot replicate. The classroom of tomorrow will be a symphony of code and consciousness, a place where artificial intelligence unlocks the ultimate potential of human ingenuity.